In chemistry, there's a lot of conversions, a lot of, what they call stoichiometry, and you get into these things. And one of the most common basic ones is converting grams of some substance into moles, right? And again, there's a previous video on what moles are, but it's a huge lump number. And the way to do it is, I had this like genius TA when I was in college. I went to UCSC, he was a molecular biology major. And this guy, he came up and he was like, looked all punk rock, and he was like, hey man, like the key to chemistry is you don't even have to understand it. If you can get your units to cancel, you're right every time. And it was like kind of a weird speech, but actually it totally makes sense. So here's a typical problem. You might have, like, they might say, if you have 4 grams of oxygen gas, how many moles do you have, right? How many moles is that? And according to this guy, which I totally agree with, you don't have to know much about anything to make sure the answer is right. And what you do is you start with what you have. You say, I have 4 grams of oxygen, right? And I don't want that. I want moles of oxygen. I don't want grams of oxygen. So all you have to do is cancel units. If I know that I have grams of oxygen and I don't want grams, I then put them on the bottom. And the basis for that is this, right? In math, you think, what is 2 over 2? They cancel. They're gone. It's 1, right? Similarly, what a lot of people don't know is, what is, x over x? They cancel to 1. They're gone. But you can actually do that with units as well. So if you had like this problem here, what are grams over grams? They cancel and they are gone. So I know from the problem that I have grams and I don't want them. So this is this guy's whole speech, which I agree with. So I put them on the bottom. Done. What do I want? Well, I know that I do want moles of oxygen, right? I'm basically done with this problem. I know based on the basic laws of math that the grams of oxygen are going to cancel. The real question is, so what? What do I put in here and here, right? This is a conversion factor. Like for instance, centimeters to inches or miles to kilometers. What is grams to mole? And it is not uniform. It depends on the atom we're talking about. So grams to mole for oxygen will not be the same as grams to mole for nitrogen, and it won't be the same as grams to moles for whatever, tungsten, right? Where do you find that? That's where you get onto the periodic table. The periodic table gives you the masses of each atom is already in the units of grams per mole. So you go on your little periodic table. I should show you one like digitally right now, and it'd be super impressive, but I don't have one with me. But when you go up, you're going to look at oxygen. Of course, you don't have O2 on the periodic table. You have O, right? And you'll find your O. Oh, here's O. And you'll know that it has an atomic number or whatever. And then down here, it'll have its mass. And its mass is 16 grams per mole. Not the number of protons, its mass is 16 grams per mole, right? So whenever some kids mess this up, they go, okay, 16 grams here per 1 mole. Remember, it's always per 1 mole, and the 16 goes with the grams. The number, the mass, goes next to the grams, and the mole is always has 1. So now you're done. And now you just do a little math. Here's the best part. Oh, magically, grams of O2 cancel. I'm left with the correct unit, so I'm already right. And then I just do this division, whatever, 4 over 16. It looks like I have 4 over 16 moles of, oh, that's nice writing, of O2. And actually, guess what? I totally just lied to you, and I'm glad I did. This mistake is something you can learn from. This is not the molecular weight of O2. This is the molecular weight of O. Make sure you keep that in mind. Oh, I totally meant to mess up so that you would learn. No, actually, that happens a lot, right? So you're going to say, you look at O and you get all lazy and you go, oh, 16. I don't have O. I have O2. Double it. This is 32. Good save. So now I have 4 over 32 moles of O2. Of course, you can actually do that math. It's 1 over 8, which I don't really know without a calculator, but I think it's like 0.65 or something. Doesn't matter. Do this in your calculator. So you went from grams of oxygen to moles. And this mistake I made deliberately, don't make that mistake, and actually it happens a lot. Especially O2 is pretty straightforward. You just double 16. What if you had H2O, right? You would add both H's and 1 O. What if you had a huge long molecule? You'd have to go on the periodic table and add them all up, and that is your molecular weight of that molecule. So that's it. That's how you get from grams to moles. It's pretty straightforward. And remember, if you're struggling in your chemistry class, your local high school, take it online at Silicon Valley High School and get your credits there and have them transferred back.